As the title of the talk already have mentioned that I'm going to talk about the respiratory diseases. This is my core area I work in. I primarily work in 3 different diseases: asthma, COPD, and lung cancer. So what I'm going to show you today is how the advanced drug delivery system can be used to combat these diseases, and why someone should be working on the respiratory diseases. I know everyone works on multiple diseases. Neurological is nowadays, everyone talk about Parkinson, Alzheimer's. So many different people work on lung diseases, cardiomyopathy and stuff. But I have specifically from my lab, from last almost a decade, I have graduated multiple PhD students. My all research is in this area only. So I'm going to show you more on all in this area. And in this hall, if I manage to change a mentality of one person who divert his area to respiratory diseases research, my talk motive is nicely done for the day then. Okay. So before I start, actually, I want to tell you that I'm coming from, I don't think this is working. I'm coming from this country called Australia. I'm born and brought up in India. I proudly call myself still as an Indian Australian. I'm coming from this one of the biggest state called New South Wales and a beautiful city called Sydney. And I believe everyone knows these 2 important, beautiful features or the hallmark features of Australia called Sydney Harbour Bridge and the Opera House. They are not very far from the school and the university I am based at. So this is one of the building of our university. Our university is in a top 100 QS ranking, and it is one of the #1 young university in Australia. This is just a latest edition of one of the building of the University of Technology, Sydney, but the main building and the School of Pharmacy where I'm coming is this building, which is called as a Graduate School of Health. Now, the Graduate School of Health have 6 disciplines. They have pharmacy, they have physiotherapy, they have psychology, speech pathology, and orthoptics. I'm also a part of the Hunter Medical Research Institute. It is a part of the University of Newcastle, and most of my human samples for the study, it comes from Hunter Medical Research Institute. I'm also a part of the University of Sydney on an honorary appointment, where my students do all the translational work in a centenary institute. All right, now, before actually I start, I think this is a common question I usually ask everyone: why someone has to work on respiratory diseases and why there should be a shift on the research on respiratory diseases. I think because of the time constraint, I'm not going to ask the question. I'm going to give you all the answers, and then probably you might try to correlate your thoughts on that. So I think one of the prime reason is, if you primarily look in India, this is one of the paper which was published in Lancet, and it clearly shows that, it's not working. Yeah, it clearly demonstrates that there is a significant impact or a significant toll of respiratory diseases in India. The higher the red color you see, it is a high prevalent of the respiratory diseases in that regions of India. So if you are postulating or submitting a grant to a government body and clearly show your data that why you want to do your research on respiratory diseases, there is a big chances you may get that grant out of it. So you can clearly see there are multiple states across, India, where there is a lot of toll on the respiratory diseases. And particularly if you see, there are some of the other papers which has come out in one of the reputed journals that clearly shows that around 45% of the outpatients in hospitals, they are always having asthma or COPD. And look, this is also one of the main reasons, COPD. India is one of the biggest country where maximum tobacco use is there. And because of the smoking, chronic obstructive pulmonary disease is very common. And this is one of the major area my lab work on. The other important news articles which clearly shows that respiratory diseases is a big burden in country like India. India accounts for almost 42% of the global asthma deaths. Can you imagine? If you go in your family history, there would be definitely at least 1 or 2 persons, those who definitely have either asthma or either one or the other respiratory diseases. Not only just in adults, it's also in kids, they are highly prevalent. And in countries like Western countries where I'm coming from, kids have very much high allergic to peanuts. The peanut allergy, and it is one of the major reason of the even asthma. This is another major problem. Now, when it comes to the winter, fog comes. And a country like India, especially in Delhi, there is a lot of pollution. And when the combination of the smoke and the fog comes, it's called smog. Now, the people imagine a pregnant woman or a person who is already having an underlying condition, maybe asthma, COPD, or a lung cancer. That person has to go in that haze. How that person will survive? You definitely need some treatments. And I'll tell you, the current treatments which are existing in the market, which clinicians normally prescribe, they are not really good. And I'll tell you why in a minute in the next slide. Now, this is another important news. When I presented in Indian Science Congress in the lovely professional university, that was in 2017. Look at that. It's almost the asthma medications are increasing every year. I'll show you some latest data now. This is 2023, 3rd of November, just the last year. This clearly shows that the pollution is going every year up and up, and that is leading to a quite significant respiratory diseases. And this is 4th of July, and today is what? I believe is 6th of July. This is just 4th of July. You can see that the 7% of the deaths in India, it is just because of the pollution. I'm not making this. These are the news which I have taken out for you guys to convince you that respiratory diseases is a big burden in a country like India. Not only in India, I have presented just 2 weeks ago in Canada. Canada also had some different story of pollution. And so as in Australia, let me show you. It's not working. Okay. This is also just a very recent, on a 5th of July, another news that it is also an air pollution, not only just in winters because of the fog, but in summers also it is very high. This is Australia. Australia every year, they get bushfires. I believe everyone heard the news because we have a lot of eucalyptus trees and we really get very hot weather. Eucalyptus oil is it's like a petrol, it's like a kerosene oil for fire. And it usually catches fire. And once it catches fire, the forests burn. It not only just lead to the destruction of the wildlife, but it can cause a lot of smoke, which can cause a pollution to the society. And it's a big toll. This is a picture which is taken by one of my own colleague living in Sydney. If you see, this is a Sydney Harbour Bridge. This is on the other side of the Sydney Harbour. This is Sydney Harbour Bridge on the top, where the flag is on the top. And this picture is taken from the North Sydney. University is on the other side. And can you see the smoke in the air? Normally we have a clear blue sky, but this is just all coming from the regional area because of the bushfires. It is not only just in Australia. In Canada, they also have bushfires. Not only just go to the Canada, let's go to the other places. I don't know, I'm clicking at the right place. This is in United States, in California and there's plenty other regions and geographical locations around the globe. Not only just the pollution, there are many other factors which contributes to the respiratory diseases. This is I just presented 2 days ago in Malaysia. This is just in Malaysia. Indonesia burns the forest and all the smoke comes to Malaysia and Singapore. And I'm not going to read these. These are just to show that there is a high need actually of the research in this area. Now, chronic respiratory diseases, actually it's an umbrella term. It can be asthma, COPD, which is a chronic obstructive pulmonary disease, and lung cancer. These are the 3 main diseases my lab work. But everyone have just come out of COVID, right? COVID is a respiratory disease. And we all sitting here because we have a vaccine. If we don't have a vaccine, I don't think this would be happening face to face. We all would be sitting in front of computers in our shorts in the house where no one can see what you're wearing at the bottom, but sitting with a nice shirt in front of computer. This is what everyone did for 2 years, including me. But we are here. And that's also a respiratory disease. Imagine, it's a big toll. And these respiratory diseases actually causes 4 million deaths actually annually just because of all these different diseases. Tobacco smoke is one of the main reasons which cause the respiratory disease. And India is a high user of the tobacco, and that can lead to quite a number of deaths across this country. Let's go to the other diseases. In asthma, I think there are 300 million people, they have asthma, and 18 million people in India, which is costing an almost of around 2.7 billion of Australian dollar just for one disease, just for one disease. In COPD, which is because of smoking, there are 64 million people, and it is the third highest ranked disease for the deaths across globe. In India, there are 22 million people which is having COPD, and it costs almost around 1.1 billion Australian dollar. In every family, there is 1 and 2 person who smokes or take tobacco in one or the other way. In our countryside, which we call in villages, people still have a wood fire. They cook the food on that. The woman who is cooking, sitting in front of that wood fire, definitely been inhaling that smoke. That can passively still cause COPD. And COPD is irreversible. It can never be reversed. Lung cancer, it is one of the major disease. And where should I click? I don't know, there or here? And it has a 5 years survival rate. And it is also one of the major cause of the death in India. Infections are completely growing. Influenza, as we come to the winter, everyone just go with a handkerchief with a blowing nose. And that can even cause to a lot of deaths. And you can see 43 million people episodes, particularly kids and elderly patients, go with infection to the clinic. Now, in every or any of these diseases, whether it's asthma, COPD, lung cancer, the main three features are inflammation. People have difficulty in breathing because airway get congested, in simple terms. And it happened because there is a lot of pathophysiological changes, particularly on your epithelial cells. It is called as a remodeling. And let me show you some data. All right, so when any patient get any of the respiratory disease, they go to a respiratory physician. The first thing that respiratory physician actually prescribe is the corticosteroids or the beta-adrenergic agonist. Today also, you go to the clinic, they will give you only these two things. How long you will take that? There is a thing which is called as a steroid insensitivity. It means the steroid will stop showing action. It has a threshold. Once that threshold will reach, these particular two things will never work. Never work. And I can bet you. So what we need something new, developed technologies. And my area of research being in India, particularly promoting in a Western society, is more towards natural compounds. So in my lab, I do work on natural compounds, which is 70%, but not to run behind the race, because people talk about mRNA vaccine and short non-interfering agents and stuff. My lab also works on oligonucleotides and also microRNA inhibitors. But in today's talk, I'm only going to show you my data, which is on the left side, and because India is a big industry of the pharmaceutical. Now, everyone talk about, beta-adrenergic agonist, salbutamol, and nowadays, what you call that? There is another top inhaler in the market, I can't recall, fluticasone. Fluticasone is one of the major drugs which is used in respiratory diseases. They will have a threshold. But why the plant-based therapies are much useful? The simple answer, everyone, a layman person, you ask your grandmother, she will say, plants are better than the compounds because they have lesser side effects. They will not going to cause you more damage as compared to you take a chemical compound, because it always have definitely some unwanted effects. But the real answer is, Ayush Ministry has signed with WHO to set up a global traditional center for the complementary and alternative medicine. It is already there, set up. I've been to states in Houston, and I was on an airport, and there was a big Himalayas products shop there. You go to Australia in any chemist warehouse, any chemist shop, the first 20 shelves is full of complementary product. All Chinese, Asians, they rely heavily on that. You go to your house, Go to your medication shelf, I can bet 40% product contains plant-based products. No one can argue on that. This is another important thing. This important center had made a deal of US dollar 3.5 million. You talk about chemical compound industry, we talk about mRNA vaccine. This is the reality. This is the coming reality in today's time. The most important companies in India which are doing a famous and quite a renowned business in nutraceuticals, these are the one. And particularly if you really look, this is the graph which clearly shows the revenue which has been continuously increasing every time with the complementary and alternative products. I'm not going to read the value, but you can see this is just at the end of 2022. And you can see herbal products of the Ayush is almost causing that much of the money. It is creating a revenue for a country like India. The story never ends till here. This is the reality of the different countries. Leave India. You go to the North America, Europe, our Asia Pacific where we're sitting, South America and even Africa. You can see the trend. Till 2029, the nutraceutical market is going to touch that skyrocket thing, clearly showing the demand of the respiratory diseases and the products being used in that time. If we really talk about the different dosage form, they are normally used powders, extracts, syrups, and look at that, the trend. But what we're doing in our lab, we're trying to do that in a novel advanced delivery system like Dr. Javed was talking about, nanoparticles. And those nanoparticles, we are collaborated. My lab has been a very strong collaboration with one major respiratory company in Ireland. It's called Aerogen. Aerogen is a very well-renowned respiratory company, and most of our projects to the human translational, they usually been looking after. Now, let me show you some data. This was a study which was done by two of my students, Jinying and Elaine. Those are the two students, and everyone works on curcumin. India is called as a gold is curcumin. Everyone uses curcumin in every country in one or the other form. This is a very old paper. You can see 2018. They were very old paper. At that time, I did curcumin in liposomes and niosomes both. I'm not showing you formulation data. I'll show you the real-time biological data. I have done these. I have done all physicochemical characterization in terms of the particle size, PDI, in vitro, whatever you want to say, SEM, TEM, they all are there in that paper if you want to refer. These particular liposomes clearly showed that they actually reduce the level of IL-6, IL-8, TNF-alpha and IL-1-beta. They reduce. And these are the four main hallmark features which usually get upregulated in asthma. Moving across, we also did the niosomes. And niosomes also showed the similar results. So one of the Elaine did liposomes and Jinjing did the niosomes. So they were the two students, that was their project. Now, if we move on, this is another drug called naragenin. This was done between my PhD student, Ridhima, and the visiting students, He-Ching and Ching-Ming. And they actually have shown that naragenin actually can reduce significantly the anti-cancerous cell on a A549 cell line alongside and all the important, the cytokines, IL-6, IL-8, TNF-alpha and IL-1-beta. Then we did also work on quercetin. That was done by Divya, which is on that picture on the left. And she actually, and along with David, they also clearly shown this, but we didn't get any results with the TNF-alpha in this particular study. There was another study of the Celestrol. In Celestrol, we only focused on IL-1-beta, and that was a very clear dip that all the progression of the asthma was controlled by IL-1-beta. All these studies are done on human cells. They have not done on a basic, the cells which we normally bite and just grow. They are the ones which have been obtained from the patients using the bronchoscopy. I'm going to show you one of the study which is with the rutin in detail. It is still in patent at the moment. So rutin is very well known for multiple activities, but what we showed is it is quite effective in the lung cancer and also in the remodeling, particularly managing the oxidative stress and apoptosis. A part of this is actually in patent, which the data I'm not showing. So what we have shown that when anyone smoke or any particular pollutant comes, it always trigger your epithelial cells and macrophages in every disease. Once it triggers there, your reactive oxygen species affected and they go alter. And that actually can lead to the disbalance between the oxidative stress and the reactive or antioxidant species. And that can also lead to the oxidative stress, and then your cells can go to that cell death, which is the apoptosis, and also can lead to the recruitment of other inflammatory cells and can cause your cell damage at the end of the day. Now, what we have done in our study, we have shown this. I can just jump straight to the image. We have clearly shown that up to 20 micromolar of the rutin, it clearly can kill the BSB2 cells treated with the lipopolysaccharide, which is inflammation. And we have also shown that with the different other studies, during the oxidative stress, we have measured the nitrate levels in those cells. You can clearly see that it is exactly following the same trend. Then we have done the immunohistochemistry, and in immunohistochemistry, you can see the fluorescence intensity in the control is very low. And when we are going down from the 3 micromolar to 5 micromolar of the rutin treatment, it actually significantly reduced the oxidative stress. Now let us look at the apoptosis. Apoptosis also with the immunohistochemistry, what we have shown with the annexin, you can clearly see it is been reducing with the 4 micromolar of the rutin nanoparticles treatment. Okay, now when we done the anti-cancer studies, it has also shown that it has been continuously reducing the lung cancer cell, which is the A549, and they also have been affecting the migration and proliferation, which are the two major hallmark features of cancer. And you can see the apoptosis, which is the cell death of your cancer cells, was quite high, which you can clearly see with the high intensity of the fluorescence at the end with the 20 micromolar treatment of the rutin nanoparticles. So what we have shown in this study that there are two different processes. One is through the oxidative stress and apoptosis, they get inhibited when we give the rutin nanoparticles. And the same thing we have shown in the cancerous cell as well through the MMP9. Now, this is another study, berberine. Berberine is very commonly used in China. You ask any Chinese, they use berberine in every house. We have shown that it is quite potent on the anti-cancerous cell, and this has been done by my postdoc and a PhD student, and it can clearly show, that the various mechanisms in cancer that have been affected are the proliferation, migration, epithelial mesenchymal transition, and the apoptosis. Similarly, we have also done the studies in the cancer. This is another cell line we have used. Here also we have shown some of the major proteins were downregulated with the treatment of the berberine nanoparticles. We have also done berberine nanoparticles so we prepared berberine nanoparticles with two different polymers, monolin and phytonterol. That's why they have multiple papers and studies being published. This was done by my research assistant Vikas and a postdoc Keshav, and that clearly showed that there are a lot of proteins which were being downregulated with the treatment of the berberine nanoparticles. There is another study we done in a cigarette smoke. This study we done with the University of Manchester in UK, and that clearly shows that when the cells really get affected with the cigarette smoke and giving the berberine nanoparticles, it actually reverses the pathogenesis of the disease. Moving forward, we have also shown the same proteins, and you can see there are different mechanisms which have been targeted, which is the oxidative stress, inflammatory genes, specifically COPD related genes, and the senescence. Senescence is nothing but it is a new concept which is called cell aging. How quickly your cell die. Because your cell organs are made up of cells and then tissue. So if cells start dying, ultimately the tissues start collapsing as well. We have also shown the remodeling. Remodeling is when your epithelial cells start changing the morphology. And we have clearly shown because of the TGF-beta it happened. But when we are giving the berberine-loaded nanoparticles, the TGF-beta actually reverse and your cells get to the normal morphology. This is one of our industry project. The Diarora is one of the Melbourne-based company. They prepare cosmetic products of agar wood. Agar wood is very well known for sleep in Middle East. What we have done, this is an oil, we have prepared a nano emulsion, and that nano emulsion we have tested for the different diseases like lung cancer, in smoke-induced, the COPD, and this study was done with Aerogen. So currently this is being taken on a human testing with the Aerogen actually. The cancer part of this is still under patent, but all the oxidative stress, COPD and asthma studies are published. There is another study which is done by my master student, Rania, and she had clearly shown that this nanoemulsion can actually be targeting various inflammatory mediator, pro-inflammatory cytokines and antioxidant enzyme in macrophages, which is also an important cells which can be triggered due to the smoke as well as the asthma. There is another study we have shown where the two important hallmark features, IL-6 and IL-8. This study was done, she's a doctor, medical doctor, who came to the lab to work for 1 year, and Juman, and she did all these studies, and she's currently been moving forward to her PhD using the same emulsion. There is another study we have done with the Zirumbun, which is the latest published in 2023 last year. That is also in that study we have shown that it triggers quite a number of the proteins. Just because of the time, I'm sorry, I'm just running, but happy to talk later to anyone if you want to talk. Similar study we have done in another particular compound. This is one of the Indo-German company. This is particularly the company I believe is Medicinal 9. If you Google it, you can clearly see. They have developed a suspension which has clearly shown effectiveness in COVID-19. And they have done the human trials and the product is in the market. But that product we have used to test on anti-cancer in our lab, and this is published. This is another study we have done. They have a revised version of that Medicinal 9, which we are currently testing in the macrophages, and that paper actually we are currently writing. So Yochim, this is another study from another company called Pharma Biotechnologies. This is my master research student, Sophia, who had clearly shown that the liposomal curcumin, this is a marketed product. Plexosome is a marketed product, already in the market. This is developed by the University of South Australia, and we have currently used it in form of the cigarette smoke. So that clearly shows that it actually reduces all the important hallmark features in COPD. The second important study, what we have done in lung cancer along with COPD, it has also shown the similar effects. And one other paper which is they all are 2024 papers. This is just recently published. Oops. This is just recently published where we have shown IL-6 and IL-8. IL-6 and IL-8 and IL-24 which have been affected using those particularly curcumin liposome plexosome. This is another study we just published a week ago. We have shown that ribavirin, which is an antiviral drug, it is commonly used as an antiviral, but we have repurposed it for lung cancer. And we have clearly shown through the different in vitro mechanism, very detailed study. Professor Sachin is here with whom we have done this study in India, half of the part, and you can see quite a significant in silico data had come through 2 different labs. So this was a collaboration between 5 different labs across the globe, and it just published in Life Sciences just a week ago. These are some of my studies, and the berberine particularly, SBS is one of the well-known channel. They interviewed me for my berberine study. Once they have, this berberine study they published, after that my own university interviewed me, but the berberine story is published by 35 different countries in 35 different news channels, my research. If you put on Google my name and berberine, I have just taken some of that. There's plenty of news articles you will see with berberine across the globe. This is still in a translational. We are on an animal studies pathway seeking more funding from the industry. This is another study on a very cellular, which my lab is looking into the 125A and B inhibitors. So in just nutshell, when any person have COPD and they get infection, like in winters, very common, they get infection. So what we have shown that these are the 2 microRNAs, they usually get upregulated, and they happen because of this mechanism through NF-kappa B. But when we inhibit when we inhibit this microRNA, which is on the top, it actually reverses everything. And this is currently we are encapsulating into the dextran-based nanoparticle. And why are we doing dextran-based nanoparticles? Because macrophages love sugar. And if our nanoparticles are dextran-based, it would be attracted by macrophages. It could be a targeted effect, and that can help, particularly in kids and elderly patients, where they have COPD and get cold, and it can lead to death even. Now, this is another asthma study. I'm not going in this in detail. We have shown quite a number of features in an OVA model, but which is a commonly used model across the globe. This data is still unpublished, but the main thing what I want to show you is the next slide, that anti-IL-13, which we got from our UK collaborators, we are also encapsulating in nanoparticles because it is reversing all the hallmark features which I have shown you on the previous slide. I think happy to talk in detail later. If anyone want to know more details, you can see that it has completely been resolving the histopathology as well. The pink color are the mucus cells, and you can see in control they are very high, but with the anti-IL treatment, how significantly it reduced. And we are currently just trying to put in nanoparticles to have more of a targeted effects. I get a lot of emails from different lung cancer patients across the globe because of the story being published in different language. These are some of the emails you can clearly see from, most of the emails I get from States and Europe. And I have hidden the names though because of the privacy purpose. But most of the people, they usually ask, can we take that berberine? So my answer to them is, berberine is available in a market, but you must consult your clinician. It is a nutritional supplement, but it may also alter drug-drug interactions or any kind of those interactions. So it's better to have a consultation with your clinician before you take that and before our product comes to the market. Now, I would like to thank actually particularly the organizing committee, Dr. A. Ramkishan, Dr. T.V. Narayana, Dr. Sisla Ramkrishna, Dr. Rupkar, and also Dr. Rao Valamudi for inviting me here to talk to every one of you and the organizing committee and the chairpersons to being here with me. My research team, some of students have graduated, some are still going on, and a lot of other collaborators in Australia I closely work with. With this, thank you so much everyone for being patient. I'm sorry it was a lot of data and I was rushing, but happy to talk to everyone later if someone is interested. Thank you so much.